Okay, recall the double angle formula for cosine. We have cosine 2 theta equals cosine squared theta minus sine squared theta. Okay, double angle formula for cosine. Now, also remember this, that we played around with this. And for example, if I replace the sine squared with 1 minus cosine squared, I get this. I get cosine squared theta minus 1 minus cosine squared theta. See, all I did was replace this with this. And then I get this. I get that cosine 2 theta is equal to cosine squared theta minus 1 plus cosine squared theta. Yeah, just clearing the parentheses. Or another way to look at it is cosine 2 theta is equal to 2 cosine squared theta minus 1. Okay, now let me just think about this a second. Notice that we have this situation where we have theta here and we have twice theta here. In other words, this right here is double this one. So let me just make a change here. Let me rewrite this as cosine theta equals 2 cosine squared 1/2 theta. Yeah, same thing, right? The point is, there's nothing special about theta. The idea is this angle is twice this one. And that's the situation we have here. Now, what I want to do, I want to solve for cosine squared 1/2 theta. Okay, so here I go. On one side, I've got cosine squared 1/2, and actually I'm going to solve for cosine 1/2 theta. So on the one side, I have cosine squared 1/2 theta, and on the other side, I have this. I have 1 plus cosine theta over 2. See? I just added 1 to both sides and then divide it by 2. So just some basic algebra. Now, I'm going to square root it, and I've got cosine 1/2 theta equals plus or minus the square root of 1 plus cosine theta all over 2. Now, this is a half-angle formula for cosine. Half-angle formula for cosine. Now, notice it's got plus or minus out front. I'll show you later how we could determine is it plus or minus. We'll look at that in a minute. But first, I want to get the half-angle formula for cosine. Okay, so to get the half-angle formula for cosine, I'm going to go back to this thing. We have cosine squared theta minus sine squared theta, and that equals cosine 2 theta. So this is something we're familiar with. And this time I want to replace cosine squared theta with 1 minus sine squared theta. So I've got cosine 2 theta equals 1 minus sine squared theta minus sine squared theta. Okay, there we have it. Now, and this is going to be 1 minus 2 sine squared theta. Now, I want to play the same game I played earlier. I notice that on the one side I have cosine 2 theta, and on the other side I just have sine theta, sine squared theta. In other words, this angle right here is twice this one. So let me do this. Let me write this as cosine theta equals 1 minus 2 sine squared 1/2 theta. Yeah, like that. Now, I'm going to do the same thing. This time I'm solving for sine 1/2 theta. So if I solve for sine 1/2 theta, go through the algebra here, I have sine 1/2 theta equals 1 minus cosine theta over 2. See? And you can go through here and check that out. But that's the way it would look. You can think of it as swap sides. I brought this over, swap sides there. But anyway, you can go through there and check that out. And this is squared here. Then I'm going to square root both sides, and I got, I've got sine 1/2 theta equals plus or minus the square root of 1 minus cosine theta over 2. This is the half angle formula for sine. So now let's take note of what we have here. We have cosine 1/2 theta equals plus or minus the square root of 1 plus cosine theta over 2. And the sine one is like it. We've got sine 1/2 theta is plus or minus the square root of 1 minus cosine theta over 2. So there are two formulas for half angles. Okay. Now, let's suppose that we're given that sine theta is equal to 3/5, and let's suppose that we're in quadrant 2. So we're in quadrant 2. We're given this information. And what we want to do is we want to find the half angles. So if sine theta equals 3/5, what does sine of 1/2 theta equal? Well, let's think about if theta is in quadrant 2, what is 1/2 theta? Well, let's divide through by 2. So I've got theta over 2 less than pi over 2 greater than pi over 4. So it looks like 1/2 theta would be in quadrant 1. It's going to be between pi over 4 and pi over 2. So this is in quadrant 1. Now that right there tells us that we're going to be using the plus. Now, if this had happened to be in quadrant 3, then we would use the minus. Because the fact is, this tells us, so theta over 2 is in quadrant 1. Sine and cosine, they both have values, positive values in quadrant 1. Okay, so now we've got that taken care of. Now, I've got to figure out what cosine theta is. Well, we've got 3, 5. This is sine. Opposite over hypotenuse. The adjacent side is 4 from Pythagorean theorem. So now here's what we have. We have cosine theta is equal to 4/5. Now we can find cosine 1/2 theta. It's just going to be 1 plus 4/5 over 2. There you have it. And we can do the same thing for sine. It's going to be 1 minus 4/5 over 2. Okay, now we can simplify, we can make these look a little nicer. I could multiply through by 5 on the top, and what I'll get is, 5 plus 4 over 10. See, I just multiplied this by 5, this by 5, and this by 5. And now we get the square root of 9/10. And we could do the same thing over here. I could multiply through by 5, and I get the 5 minus 4 over 10. And that would be the square root of 1/10. So there we have it. So these are the half angle formulas, and this is an example of how you could use them. Okay, now let's suppose we want to find this. We want to find the exact value of the sine of, let's say 15 degrees. Okay? We're given that now. 15 degrees, of course, is not one of our angles on the unit circle that we work with. So we probably don't know the exact value of it. However, we do know that we do know about 30 degrees. That's one of our special angles on the unit circle. So why don't I write this as 1/2 of 30 degrees? That's something we're familiar with. Now that's the same as 15 degrees. It's just a more complicated way of writing it. Well, look at this. This is theta. We've got this formula. 1/2 theta equals the square root of 1 minus cosine theta over 2. And it's plus because we're in the first quadrant. Okay? So we're in the first quadrant here now. So let's see how this looks. Theta is equal to 30 degrees. So we need to figure out what cosine theta is. Well, cosine of 30 degrees is the square root of 3 over 2. Well, heck, we pretty much have this because now we have this. We have the sine of 15 degrees, which is 1/2 30, is equal to the square root of 1 minus the square root of 3 over 2 over 2. There it is. That's the exact value of the sine of 15 degrees. And we could clean it up a little bit and say, well, this is going to be 2 minus the square root of 3 over 4. And that is the exact value of the sine of 15 degrees. And we got that from just using the half angle formula for sine.